Hi, welcome to our new video segment, TinkChat. In this new segment, we'll be talking about 3D printing in real-life situations and how it's applied there.
Yeah, talk a little bit about the big world stuff, how that can all be distilled back down to an educational setting, why the students are learning this technology, because, well, the end goal is to eventually get to the big world stuff.
Yeah.
Yeah.
So I'm Andy from Tinkerine.
I'm Eugene.
So before we get to our first topic of this new segment, a little about us.
Yeah, well, Tinkerine is a 3D printing manufacturing company. We design and manufacture everything here in, well, Canada, Vancouver. Yeah. And we have a huge emphasis on education. And not just education from the perspective of, well, the word education. We really care about really finding that solution for teachers so that they can get students to use
start
this,
on it. Dip their hands into this technology.
Well, use this technology to facilitate critical thinking and go through the design process. We'll chat a little bit more about that as we start getting into the topic.
Yeah.
But that's kind of us in a nutshell. Behind us is our production facility. You can see a couple of machines, little pros in the back. But we're just using that as a backdrop for now. We'll maybe figure something out later.
Yeah. So for today's first topic, we're going to be talking about architecture of 3D printing.
Yeah, cement printing, 3D printing with cement. That's kind of where majority of the I'm going to call it housing projects in 3D printing is right now.
Yeah.
Unlike traditional manufacturing methods for housing, so wood framing in North America. If you look at Asia, it's mostly like cement. Constructions. Yeah. Or even going to warehousing construction where you have tow-ups and then you kind of build them on set. 3D printing, I think, for the housing or architectural construction is an evolution of where we're going. It's automated. It's robots doing the construction. And if those of you that don't know, 3D printing is a technology that takes layers upon layers of material lay down one at a time until you have kind of the vertical height. And so, these machines are going into these construction sites pre-programmed, or somebody is pre-programming them or pre-drawing.
So they design the outer layer first.
The house. Yeah, they can design the whole house.
Yeah.
And then the machine, most of the time, only creates the four walls. The outer walls. So they then go back in later to add the roof or something else, but they don't usually close off the top.
Now that I think about it, one thing that popped into mind. So how would they actually add the insulation or like the wiring for plumbing or like anything like that? And while the house is being built, would we pause the 3D printer or like?
No. So that's part of the design process. When you're designing something, most of the 3D designed homes are hollow. They've got this honeycomb structure, just like what you would see on the desktop 3D printer. Adds a little bit of structure.
Would you put insulation in it then?
Well, I suppose you can do it then and there, but I believe most of the time they wait until the structure dries and cures because it is cement.
Yeah.
And then they go in with little pilot holes, or the holes are pre-designed in the actual walls, and then they fill it with insulation through those holes, because the inside of the house still gets finished. They still get finished. And so at that point, they can plug the hole once the installation's going.
Oh, okay.
So, rebars can be done when it's printing. Reinforcement in terms of like wire meshing can go in while it's printing. Okay. Actually, machines, I believe, lay those in while it's going, or construction workers can actually go physically put the rebars in.
Oh.
But insulation, I haven't seen one yet where it's done at the same time.
Yeah.
I think also cement does have a certain level of like insulation value.
Oh.
So perhaps it's not even needed because you have a cement on one side, you have air gap in the middle, and then you have another cement.
I'm just thinking like in North America, like in some cities, it gets down to like -40. How would 3D printing houses actually help them there? Like if we don't put any insulation in between. Like in Calgary, it's like it gets to -40. It's pretty cold.
Yeah.
And would it be not as popular, I guess?
No, I think we would probably see traditional housing stuff translated over. Like that's why it's an evolution. It's not totally drastic.
Yeah.
So your traditional like roofing framing still goes in.
Okay.
Because you don't know what happens when you put cement arches that go over, right? You
I guess there's still a lot of testing right now.
Yeah, it's in super early stages.
Yeah.
And well, regulations haven't caught up yet. Seismic testing hasn't caught up yet. So all these things need to get there, but in order for I think the industry to really push it forward, I mean we have some companies doing that now today, but only few because there just isn't enough people that know how to do this. Right. So, and that kind of brings us to the article that we pulled up, and it talks about a home that was constructed in 2018.
2018.
Again, the outer four walls were the ones that was printed. I believe they had reinforcement bars put in.
Okay.
And the company went in and finished it off with the roof that was done traditionally, and the interiors was then finished. I'm not sure if there was insulation put into that because the house was down in Texas.
Yeah, it was down in Texas, so climate's a bit hotter than us in Vancouver or any other cities in Canada.
Yeah, but it's really cool though. The house was done in 24 hours.
Yeah, 24 hours.
First beta, the first beta construction was $10,000 to make.
But I think they said that they can actually tweak it down to like $4,000.
Yeah,
just for making it.
The ideal scenario is to bring the cost down.
Yeah.
Right. I mean, if the homes can go down to 4,000 for it's almost like a studio suite, single bedroom, about 600 square feet, something like that, 400 square feet, 600 square feet, and to be done in 24 hours. Yeah, that's pretty amazing.
Nice. Right? Yeah, it's all these applications, like even for like disaster relief right now.
Yeah. Like, I mean, imagine deploying the technology, the machines, and then having someone remote or even physically there design the house for that environment, and then having a machine fabricate it right there and then. 24 hours per house. You can start to put people in. I mean, Dorian just went through some parts of North America, so yeah, I think that's just what we see here on Earth. But we can also do the same thing, well, say on Mars. Yeah. Right? NASA just recently also did a competition
on designing.
Habitats. On Mars.
Yeah, on Mars.
And so there's two teams that went and competed. The prize pool is really big for a competition of this scale. I mean, the scale is not small by any means. It was $700,000 for the prize pool. Two teams won. First place was a company down, I think, in the U.S. Called AI Space Factory. They got $500,000. It was a group of individuals, a company that got around the idea of building a habitat on Mars. And then the second was Pennsylvania State University, who won $200,000.
That's interesting because Penn State actually has a couple of our printers. I wonder whether or not they use our printers to actually do any prototypes first. I
mean, I would not be too surprised. I mean, the technology that we see on desktop printers are applicable to large scale ones. Concept is exactly the same. I think that's what's really important is that students that learn on these desktop printers, students that understand the creative process, the design process, all these skill sets that are built up now can be applied when they get into industry, when they start to go into businesses or crazy competitions like this one. And to build something that we've never seen before.
Yeah, especially when design is such a prominent, topic right now. Like everything is about design, like architecture, all these competitions, even like landscape and geography. Like all those include designing it. So.
Yeah, well, it's a pretty big thing. I mean, some of the biggest companies in the world base their whole entire companies off of design. So
it's definitely a key element in the future.
Oh, for sure. Well, as we start to see more automation, as we start to see more robots kind of being in play to make our lives a little simpler, I think the skill sets start to shift a little bit more towards that creative element. And then leveraging the tools to kind of get what we want created and built so that we can, do more amazing things. Right. So we see a lot of this in
K-12.
In K-12, and so we see a lot of what the students are doing. We see a lot of what the teachers are helping the students facilitate in their skill sets, and there's a lot of these interesting moments where interdisciplinary moments happen, or a student was able to really tap into their interest and passion. That engagement level for this technology is one of the key elements, I think, to really switch things up.
Mm-hmm.
It's not just about theory anymore. It's not just about learning what science and what elements do, but it's actually taking it and applying it in a scenario that the students can go, oh, that's really cool. I didn't know that.
Well, especially when you design something, you see your own design being built layer by layer right in front of you. You can just see the sparkles in the children's eyes.
Yeah, I like to say it blows their minds.
Yeah, I mean, it blew my mind when I first started with this technology. So thinking about them, it's definitely like a whole new world opened up.
Yeah, so yeah, I mean, the design process in the classroom is one of those elements where it does when we think about STEM makerspace. When we look at kind of even larger concepts, just from a design perspective, it's a really complex thing, right? The design process helps us take a look at these real world things and allows us to process it almost in like a structured way.
Yeah.
It allows us to look at maybe designing a habitat on Mars. What are the conditions on Mars? We don't know that. We have to do some research. It allows us to inject a little bit of our personal biases in how the housing looks. Every single project will end up looking slightly different.
Yeah, well, with 3D printing, your creativity is the limit, right?
Yeah. I mean, your inspiration too.
Yeah. Oh,
right?
Okay.
So I mean, we all take inspiration from many different things. Like everyone grows up slightly differently. Everyone is in a different environment. So this technology is one of those ones where it really allows us as individuals to facilitate what we want the outcome to be. Mm-hmm. We can also facilitate, for example, if I'm going to design a shoe for the masses, right? I can then think about how my design is going to impact multiple people instead of just one person. Yeah. So it's unique in the sense that it's not just this 3D printing tool that gets you the same thing every single time. Mm-hmm. It's different for every single individual. Yeah. So that's what we see that's what we've seen in the classroom. We've also seen some stuff where some of the fundamentals have to be put in place. I mean, 3D modeling is a pretty key fundamental skill set for this technology. If we're going to be designing remotely, we're not thinking about what the technology is doing. We're thinking about what the visual space is doing. Mm-hmm.
So that's spatial awareness.
Yeah, spatial awareness, math, sciences. It's definitely interdisciplinary in every sense from what we can tell. So that's being kind of shared with us through the teaching community as they leverage our technologies to bring it into the classroom to do all that.
Yeah. Other than that, other than the fundamentals, sometimes teachers find that just by teaching fundamentals, it opens doors to other subjects as well. Like, for example, recently when we went to school, the teachers were teaching about friction. Right. And then it just led towards other concepts like driving. When it's raining, is it going to be more slippery, or like breaking the distance that you're supposed to hold? Like, it opened new doors to new concepts that probably if you were teaching traditional with theories that you would never touch upon.
Yeah, or even terminologies that may go beyond what the curriculum covers right now, right? Because there's a certain level of engagement and passion that the students want to get to know more. And we've seen a lot of teachers really play up on that. I wouldn't say play up is the right word, but they really use that engagement to facilitate additional learning. Yeah. And really not in a forced way that we've seen. The students just want to know more.
Yeah, because they're just so interested from I'm guessing, using this technology.
Yeah. I mean, they're trying to achieve a goal. If it's to make a car that moves better on a surface, then they need to do the research. They need to ask, some of those really important questions, and then apply that into an actual physical design that they can see it translate into an end goal. Yeah. So, that's what is kind of happening in the 3D printing world with regards to structures. That's what some of these things that we talked about with education. While it may not seem super connected right away, all the skill sets actually lead the students to those areas. And it may not just be architectural 3D printing. It actually could lead into bioprinting. It could lead into the simple prototyping of a design.
Well, even just 3D printing is in so many industries right now, like filming. Like all the props that you see during movies, they're probably made by 3D printer. Bioprinting, as you said, like printing a new tissue for you, or maybe a new organ.
We can talk about that maybe a later segment.
Aviation, cars, shoes, apparel, like everything.
The list goes on. I mean, this technology really touches more than just. I mean, I think a lot of people think that 3D printing is just a technology that gets you a thing.
Yeah.
And it may get you the same thing over and over again, or perhaps that it's supposed to print a trinket that you download online.
Yeah.
And that may be the case, but if you know the design process and you can do the creation, this tool is much, much more than just something that gets you, well, an object you can download online.
Yeah.
Right? Okay. So I think that wraps up this segment. Leave us a couple comments about maybe your thoughts about this segment, or just general questions you guys have about how this technology is impacting the education industry, where it's going. We'll probably answer some of those things.
Yeah, we'll answer it in the next video.
Yeah, or just in general any question.
Yeah,
as long as it's in our capacity to answer them. We will do that.
Well, also remember to click the subscribe button that's on the bottom, and the bell button as well, to make sure that when we upload a new video, you'll be the first one to watch it. Well,
awesome.
Yep. Okay.
We'll see you guys later.
Yep. Bye.
Bye.